At the end of the previous video, we finished talking about how to using hash set. So you can see we add different city, but duplicate city won't be print. And also when we're using the hash set for all the data, the order they display won't follow the order you insert one by one. The reason is hash set, we're using the hash code to easily and quickly to calculate the index of the array. So that's why the order they display actually is kind of according to the hash code value. So that's why we're not the same as the order you insert each data. If we want to maintain the order for each data according to the insertion, so instead using the hash set, we can use the linked hash set. So linked hash set, we can see earlier from the hierarchy we have. So after we have hash set, we're using the hash code function to find the index. And also we can specify the initial capacity and the load factor. So according to the load factor, the capacity will be updated. Then the hash set actually has a child class inherited from. You have the link hash set. So how to create a link hash set? They have the same constructor as the hash set function, hash set class. You can have default constructor without anything, or have any collection that will create a link hash set, or you can specify the initial capacity and the load factor. So look like they have no difference in the constructor. However, in the link hash set, addition to the using the hash code function to have the index to find the location, but also they're using the linked list to maintain the order according to the insertion. So that's why here you will see the link hash set class. They extend from the hash set class, but using a linked list implementation. That's how they can support for the ordering of the element. So the ordering actually is according to the insertion ordering. The element in the hash set is not ordered. Actually, the order, they have their own order, but they're according to the hash code order. So the element in the linked list hash set, the link hash set, actually they will retrieve the order within the order when you insert into the set. Okay, so that's why we see here your link hash set. So we do exactly the same as earlier. The only thing different is when we create a set, instead using the hash set constructor, we call the default link hash set constructor. So that's why the same thing, we still add 6 times for different city. The New York actually is repeat. But you will see when we print again, so then you will see they will follow the order. So that's London, Paris, New York, San Francisco, Beijing. But the New York, because they are duplicate data, so that's why they are not added into the link hash set. So the link hash set maintains the order for the element insert. The hash set is according to the hash code method, so they have their own order. So now if you don't want to maintain the insertion order, you want to have different order. For example, you want to ascending order or descending order. So then we need to use another set we call TreeSet. So we continue to call the tree to see the TreeSet. To see the TreeSet, we come back to our set interface hierarchy earlier we have. So we finished the hash set and the link hash set. So now we come to the right hand side. So that's where we have the TreeSet. The TreeSet, you will see, yeah, they still inherited from the abstract set, but they also inherited from the sorted set interfaces. So what is the sorted set? So then you can see very obvious from the name, right? So that's the sorted set. So according to you sort the value from your set. So that's why you can have the first and last. So the sorted by default, we do the ascending order. Okay. So one thing is if you want, you can have different comparator than how they was sorted. So that's why since they the tree set inherited from the sorted set. So the tree set actually all the data value is sorted. Then you will see the tree set, the same thing. We have 4 different constructor. Default constructor or from the collection. So now you don't have the initial capacity or the load factor. So instead you see your tree set, you can specify your comparator we learned last week. So if you want to have different order for your value, so for the student class, you want to have according to student name, or you want to according to the student ID or GPA, you can specify different comparator. So there will be the tree set will be the tree set will be in different order. So the sorted set actually is the sub interface. So they will have the first and last, they will return your value. And they have the head set or the tail set. So that's why those elements in the tree set can be sorted. So the sorted by default sorted according to your comparable interface. So remember in your user-defined class, you can implement the comparable interface and override the compare to method. So you can do that. That's by default. Otherwise, you see earlier we show you the tree set, your constructor, you can specify your comparator. So that's why they can have a different order according to the comparator you pass. So the next example, we will show you how to use a tree set. And also you can see your tree set. You can create your tree set according to the existing collection, right? So that's why we will demo to you is we will create the hash set. Earlier we create a string tree, the hash set with 6 different cities. So we're just using that hash set convert into a tree set. So since the tree set is inherited from the navigatable set and the sorted set, so you will see their order will be according to the ascending order. And also we will show you how can you using the method lower, floor, ceiling, and higher from the navigatable set interface because you all inherited into the tree set. So that's the example. So you can download the test tree set. So the first thing you see, we create a hash set. So we still follow earlier, we add this 6 cities. New York is repeated. But according to this hash set, I can create a tree set. So then we just see the create a tree set. So you see we just right away display. So display, you will see earlier we have London, Paris, New York, San Francisco, Beijing, right? So then since they changed to the tree set, there will be a ascending order. So that's why you see they will display alphabetic order. It's Beijing, London, New York, Paris, and San Francisco. Okay, so continue after we have the sorted order. Then we say what is the first and last. So you can just print the first element from the tree set and the last one in the tree set. So of course that will be Beijing and San Francisco. And also you can display the subset from the tree set. So that we call the head set. So this means all the subset before the New York. So that's a head set according to the parameter you pass. So they will start from beginning, display before the New York. So that's why you see they will display Beijing, London here. because your head set is New York. So then that's a head set, right? So then we have tail set. Tail set is start from this passing node and to the end. So that's why including New York, Paris, and San Francisco. Okay, so that's the example. Okay, so then we're using those methods from the navigatable set interface. What is the lower, higher, floor, and ceiling? So actually just give them the value. They will compare lower to which one is lower than this value. They only display one. So the first one lower than P. Okay, so the first one higher than P. So the first one lower than P. P actually is Paris. So that's why New York is lower than P. So then higher than P is Paris. Why Paris is higher than P? Yeah, because you have A. Yeah, so that's why P is alone. So P compared to P the same, but then they are down. So that's why this P is smaller, lower than Paris. So the floor, that's mean including smaller than P, but can be equal. So that's why it's New York. So then you have the ceiling. Ceiling actually is which one is in the top of the P. So including the P, so that's Paris. So then you also can pull first and pull last. So after we pull first and pull last, so that's our tree set like this. So that's our tree set example according to the value in the order. So you also have some additional method you can refer to.